So, a couple of things real quick before we start. This is going over the June 2018 Regents, and wherever I could, I gave you like some similar problems for you to try. So there are a couple of things that you need to know before we start. So the first one is to get a 65 on the Regents, you need to get 14 out of 37 questions correct. Okay, that's to get a 65. All right, so we're going to aim for 14. So if we count up, so these right here are the absolute non-negotiables. Like you absolutely must get these questions right. 1, 2, 5, 8, 9, 20, 27. That's 2, 4, 6, 7 questions. 100% you have to get those correct, okay? So if you get those 7 questions, then we just need to get 7 more correct. And even if you just pick C all the way down on your multiple choice, you have chances of getting like 2 or 3 correct. These ones right here are ones that you could definitely do. They might require like one step to know one more or two more steps, but these also can be completely done. So 2, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Technically, there are 16 questions in this June 2018 Regents that you can completely do at this point. All right, which would get you more than a 65. All right, so for the first one, the graphs of these two are drawn on the same set of axes. One solution of the system is. You should always try these questions first before you watch me on how I do them. But I will go ahead and show you how to do these all straight calculator. So first thing I want to do is plug these into my calculator. So the first one's easy, right? I have my y by itself. The second one, I can get the y by itself by just moving that 3 over, right? So I can go minus 3. So this cancels out. So I'm left with y is equal to x minus 3. So I went to my calculator and I typed that in. Y is equal to x minus 3. And then you can go ahead and hit graph and you can see, hey, it crosses, looks like about 2 times in the negative side. So automatically anything that has a positive y value, I can cross out. So that is definitely not the correct answer. So now if I go to my table, I hit second graph, and I look across from -2, I see 5, 5, which means that -2 is the solution. So I'm going to look for the point -2, 5, and that is not there. Okay, and then I want to look at, so because this one has -2, -1, that is not true. If I look across from -1, I see -4, -4. So -1, -4 is a solution. So therefore that works. If I wanted to check the last one, which is -5, -2, I go up to -5 and I don't have -2, -2. So that also does not work. All right. So let's go ahead and pause. I want you to go ahead and try this question on your own. Pause the video, try this question on your own, give it a shot, and then resume the video. All right, so you should have gotten answer choice number 3. Okay, these are both set in y equals form for you, so you just need to see where they meet or where they intersect. So there you go. All right, next question. So which statement is true about this graph? I'm going to go ahead and plug that into my calculator. So I hit parentheses. F of x is the same thing as y. I'm going to put my fraction by doing alpha y equals option number 1. So put a 1 on top, put an 8 on the bottom, close the parentheses, and it's to the, which is this little symbol right here, x power. And I'm going to go ahead and hit graph. And now I'm going to see what my graph is doing. So it looks like over here, the graph keeps on decreasing. And again, you're looking from left to right, and the graph is going down. I can prove that by going to my table, and I can see that my values for y, you see these numbers right here? These are going lower and lower and lower, and eventually they are going to get closer and closer to 0. So this is like small numbers, tiny, tiny. Anytime this is like 1 times 10 to the -10, that's a very, very small number. And eventually, if I keep going all the way down, second table set, let's just say I go to 100, and I go to my table, I should see a very, very small number, eventually 0. Okay, so I can see that the graph is always decreasing. Increasing is going to look like that. Decreasing is going to look like what we have. The graph passes through 1 comma 0. If I go to my second table set, I go to number 1. I go to second graph. Across from 1, I don't have 1, 0, so that is not true also. And the graph has an asymptote at y equals 0. We didn't study that really, but asymptote just means like the line that it doesn't cross, which over here, this is supposed to be y equals 0, right? Y equals 0 is the x-axis. If you didn't get that part, it's okay, no big deal. I want you to go ahead and try this. So which statement is true about the graph of f of x or y equals 2 to the x? Pause the video, try this one, give it a shot. And you should see the graph is always increasing, okay? All right, next question. So where I is the imaginary unit, da 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 is equal to. All right, so for the next question, I have the easiest way to do this is to store a number. So 2.4, I'm going to store that in for x, hit enter. I'm going to plug in my original, parentheses x plus 3, I is second decimal point. We're going to close that, we're going to square it. Then we have a minus sign, parentheses, 2x minus 3i again, close that, squared. So I'm going to take this number right here, write it down, negative 17.28, negative 17.28 plus, I think it's 43.2i, 43.2i. You could have stored any number you wanted besides 0, 1, or 2. I just use a most random number. And then I'm going to plug each of the other ones in. So my first one is negative 3x squared. So I'm going to plug in negative 3x squared, hit enter. That does not give me the same thing. Negative 3x squared minus 18. Does that give me the same thing as this? Nope, it does not. So I'm going to go over here so it's not 1 or 2. I'm being a little bit lazy. I'm going to go ahead and grab this, hit enter. I need to change this right here to a plus sign. I have the 18 already, and I'm going to put x and I, hit enter. Oh, look, that's the same thing as the one on top. So boom, my answer is 3. I could plug in the fourth one, and you can see that it does not work as well. Okay, try this one. Pause the video. Give this one a shot. And the correct answer is 2. Okay, do this yourself. All right, question number 8. Which expression can be rewritten? Again, this is a straight calculator question. So I'm going to go ahead and clear this right here. So I'm going to plug this into my calculator, parentheses. I already have the 2.4 stored. I can check it if I want. X should be 2.4. Perfect. So now I have parentheses, x plus 7, close parentheses, parentheses, x minus 1, close parentheses. I'm going to write down this number, so 13.16. That's my target number, and now I'm going to go back to my calculator, type in each of the ones that are here. So option number 1, hopefully it is the same thing. That would be a lot less work. Squared minus 16. Is that the... Hey, look at that. So the first one is the answer. And you should check the other ones to see that they are also, that they don't, they do not work. And you can see that they don't. All right, so go ahead and try this one. Which one can be rewritten as da da da? Pause the video, try this question. And the correct answer is 2. Okay, 2 is the same thing as the original. All right. All right, question number 9. What is the solution set of, so I'm going to pause this while I plug this into my calculator. Please do this. All right, so I plugged it into my calculator by doing alpha y equals to get the fraction bar, plugged in my original, and I'm looking for solution set. So I'm going to hit graph. So blue lines are what I plugged in under y1, and this is the red lines are what I plugged in under y2. And you can see it hits here and here at the very least. So if I go to my table, second graph, I can go ahead and look to see if I see two numbers the same. Boom, negative one, negative one half. So negative one is definitely an answer. So this is wrong, this is wrong, this is wrong. So this has to be it. And then if I check 3/2, so I go second table set, I want to do 3/2, 3 divided by 2. And if I hit second graph, I can see that my y1 and my y2 are exactly the same. So both answers work. Okay, so pause the video, go ahead and try this one, give this one a shot, and the correct answer should be 4. Okay, all right. The next one that we're going to do is question number 20. So flip to that, pause the video, plug this into the calculator using, we already did store button. So I can test to see that my x is still 2.4. Oh, my x is now 10. Oh yeah, because I did a whole bunch of stuff. So let me just go ahead and store 2.4 back in for x. Hit enter. So now I'm going to plug all of this garbage. So I have square root second x squared 16x squared. I'm going to go out of it. So go to the right, put times, and then I have x to the 2/3 power. So I do x to the, get the alpha y equals again. Option number 1 is 2/3. So 2/3. Go to the right. And then I put the plus sign. And now I have to put a little cubed here. So I have to hit the math button. Option number 4 or number 5. Number 4 is easier because it already has a cube there. And then I'm going to put 8x to the 5th. Okay, so this is my magic number, 25.812. 25.8128 something. So now I'm going to take each of my answer choices, plug it in. So I have 6, and then I'm going to do the 5th root. So math, option number 5 allows me to put, okay, that's not what I want. Okay, so let's put my 6 here. Let's put a times here. And then I'm going to do math, option number 5. There we go. So now I can put the 5th root of x to the 3rd. And I want to look for that 25 point something number. I don't have that. So I'm going to go over here. Since number 1 and number 2, the choices are very similar to each other, I can go ahead and very easily change this to a 3 and change my exponent to a 5. Okay, there we go. So my answer choice is choice 2. Done. Pretty straightforward. Go ahead and try this one on your own. Pause the video and give it a shot. And you should get choice 4, which is this one right here, is equivalent. Okay. For the next one, I had to do a whole bunch of calculator shots because my calculator did not have this function. So it says solve 2x squared plus 5x plus 8. You could do quadratic formula, but the calculator will allow you to do this pretty straightforward. All right, so first thing you're going to do is you're going to hit the apps button, which is the only purple button on the calculator. Hit apps. You're going to do polysymbol 2. Please do this with me. If your calculator doesn't have this, go switch out a different calculator. And then you're going to hit option number 1, which is polyroot finder. This one is when you're looking to do 3 by 3, like you have x, y, and z and you're looking for them. That's not what we have right now. So we're going to do option number 1, polyroot finder. This should be on default 2. And why? Because this is the order, right? The highest exponent is a 2. It says put it in a plus bi form, so make sure your calculator says a plus bi form. So go down and go over to the right, hit enter. I want my answer in a fraction, and then you're going to go ahead and hit the graph button. So hit graph to hit next. The next thing you're going to do is you're going to put your numbers in. So the number in front of the x squared is a 2, the number in front of the x is a 5, and the number that's showing by itself is a 8. So we're going to put 2, 5, and 8, and then you're going to get these two answers in your calculator. And literally everything that's there, you're just going to write it down. So negative 5 over 4 plus 1.5612 da 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 I. Okay, and then the next one is negative 5 over 4 minus 1.5612 da 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 I. Okay, so those are your two answers, and if you do that, you will get at the very least partial credit, if not full credit. Okay, so I'm going to ask you to go ahead and try this one right here. Same steps. Again, apps, polysymbol 2, polyroot finder, a plus bi form, put the numbers in, 2, 3, 2, and then hit solve, which is graph. And your answer choice that you should get is number 1. You should see number 1 is the same thing. Okay. All right, so the next couple of ones that we're going to be doing are some can-dos. All right, so I just went ahead and stored 2.4 in for x again, just in case my calculator went ahead and changed it, and I'm plugging in my original function. All right, so 2.25 is the magic number that I'm looking for. 2.25. This is already not right. This is a negative, so that's not right. So it's between these two. It says key thing, it says in simplest form. I can see that this right here, the x squared minus 9 can be factored into x plus 3 and x minus 3. And then on the bottom here, this is a x parentheses x minus 3. These cancel out, so your final answer is x plus 3 over x, which shows me that 4 is not in simplest form, so therefore my answer choice has to be 3. And I can go ahead and use my calculator to verify that that is correct. So option number 1, x plus 3, and on the bottom is x. And the reason why I did that is because if I plugged the fourth one into the calculator, I also would have gotten 2.25, but I can see that this right here is not in simplest form. So that's why I proved this to you right here. Okay, so you're going to go ahead and there's no similar problem that I found that's close to it. Question number 6, which function is even? So I'm going to go ahead and just tell you what even is. Even literally just means if I have a function and it goes something like this. Toot, toot. Like it is symmetrical with respect to the y. If I fold my paper in half with the y-axis in the middle, the left side and the right side look the same. Okay. Um, here's a maybe a better one. I go like that. Okay. So if I again fold my paper right here in the middle where the y-axis is, the left side will equal the right side. So I'm going to plug each of those into my calculator. So the first one I plugged in is y equals sine of x, and if I hit graph, I can see if I fold this down, the left side is not equal to the right side. Please do this. The next one I plugged in is x squared minus 4, and boom, right? If I cut the graph right here where the y-axis is, the left side is equal to the right side, therefore it's even. Okay, go ahead and try this one. Which graph has line symmetry with respect to the x-axis? Again, is you're looking for something that is the same on the left side as well as on the right side, and you should see that 2 is the correct answer, because if you graph it, it looks something like that, which the left side is equal to the right side. Okay, next one. All right, we're doing good. Number 10. So basically what we're doing with this question is we're just going to plug each of these into our calculator and see which one gives you a function that looks like that. Before we can do that, we're going to hit window, and we're going to make our window the same numbers as it is here. So if I see that this right here is 6, then 12, then 18. So it looks like it's every 3 boxes is going up by 6. Okay, so this looks like another 6 here, so there's going to be 24. This looks like it's 0. I know that this next box over here is going to be -6, and then this is 2. Every 1 box is 2, 4, 6, 8, 10. So this is 0. This is going to be -2 and -4. So I'm going to go to my calculator and change this. So my x min, let's go ahead and put it as -6. I could have done it as -4. My x max is 24. because I want my calculator to look exactly like this. So I'm going to put 24. The scale is going up by 2, 4. It's going up by 2's. So I'm going to change my scale to 2. That's basically just telling me how much each box is going to be. And then for my y's, it's going from -4 up to 20. So I'm going to put -4 up to 20. And the scale is going up by 2's. Okay, scale is going up by 2. So now I'm going to go here to my y equals. Let me remove this and plug in each of the ones that I have and see which one matches. All right, we're back. So I plugged in the first one, 5 cos. Cos is right here. I did my alpha y equals to get my fraction. Pi is over here above the above this little mountain symbol. So second mountain gives you that pi. Um, X close the parentheses plus 9. And now I want to see if it matches this graph. So I'm going to go ahead and hit graph. No, it doesn't match exactly because if I look over here, this is not at, this looks like 9 maybe. If I go confirm it with my table, this says 0, 14. That is not what this graph says. It is not at 0. That's 10, 12, 14. So that's not right. So I'm going to plug in each of my other ones and see which one matches exactly. Second one didn't match either. This is what I get when I graph it. The 9 cosine pi over 6x plus 5, right? I can automatically see that that does not look like the same. This is the third one. This one crosses at 0, 5, 2, 4, 5. Nope, that doesn't match. So now I'm going to do the last. And the last one does match. So 0, 9. Okay. And then it goes up from there. So if I go ahead and hit graph, I want to see if it looks like this right here. And boom, that's a pretty correct location, right? Goes from 9, goes up, goes down. Okay, good. So answer choice is 4. All right, so for this next one, I need to do a little bit of thinking. It says the profit is the cost subtracted from the revenue. So profit is equal to the cost subtracted from the revenue, right? So cost is subtracted from the revenue, which means revenue goes first, okay? So now I have to get the cost by itself. So I'm going to go ahead and add C to both sides. So this is P plus C is equal to the revenue. I want to get the cost by itself, so I'm going to do minus P. So this cancels out, and I'm left with cost is equal to revenue minus profit. Okay, so now I'm looking for the cost is equal to revenue. They're telling me revenue is equal to this thing right here. So negative 0.3x squared plus 150x, and I have to do minus the profit. So profit is this whole thing right here. So I'm going to do parentheses negative 0.5x squared plus 250x minus 300. And now I just need to go ahead and figure out what that's equal to. So you could, if you wanted to, store a number in for x, plug this whole thing in, right? All of this, and then plug each of these in and see which one matches. I'm going to go ahead and just do this by hand. So I have a -1 right here. So I can do distributive property, which means basically I'm going to switch all the signs. So negative times a positive is a negative. So negative 0.5x squared. Negative times a positive is again a negative. So that's 250x. Negative times a negative is a positive. So that's plus 300. And then I bring this whole thing down, negative 0.3x squared plus 150x. Okay, so I'm going to go ahead and combine some like terms. So what are my like terms? This and this are alike. So when I combine those two babies, I get negative, I can use my calculator, 0.8 x squared. So I can tell already this looks like it's going to be the answer. 150 minus 250. Those are also like terms, right? 150x and negative 250x. So when I combine those two babies, I get negative. I paused it because I just realized something. So I realized that over here there's a negative sign. I didn't put the negative sign here. So negative times negative becomes a positive. So that's going to change this answer. Let me go back to green. So this is negative 0.3 plus 0.5. I can do this in my calculator. If I add them, I get 0.2 x squared. So that's a negative 0.2 x squared. So these two are out. This is out automatically. If I do 150x minus 250x and I combine those terms, that's going to be the same thing as negative 100x, which so far right now it looks like this is going to be the answer. And then I have the plus 300, which is chilling by itself, so I'm going to bring that down. So plus 300, and that is answer choice number 3. Okay. Next one. So fourth degree polynomial has zeros. Zeros are literally just where it crosses the x-axis. Okay, where it crosses the x-axis. Let me just go ahead and do a highlighter. So over here, this crosses at negative 5 and 3. Negative 5 and 3. So this right now could be an answer. And then it crosses at I and negative I, which does not cross the x-axis. So automatically I can know that this is not our answer, because negative 5 and 3 cross the x-axis, but i's do not cross the x-axis. It's going to look something like this, right? All right, so if I look over here, these roots are negative 3 and positive 5. That is not what I have here, so this is also not correct. These roots are negative 5 and 3. Okay, that could be it. And does it cross the x-axis at any other point? No, it does not. So this looks like it is the correct answer. This one crosses the x-axis at negative 3 and 5. This is not it. So the only answer choice that makes sense is 2. And one more time, what I mean by the i's. So I and negative I means that it does not cross the axis, the x-axis at all. So it only crosses at negative 5 and 3. So at negative 5 and positive 3 is where it crosses. So it should go something like that. And the only one that matches that is option number 2. All right, so for this one, straight calculator question. All right, so I went ahead and graphed it. I plugged it into my calculator. I'm going to graph it only from negative 1 to 4. So I'm going to go to my table, so second graph. So from negative 1 to 4. So negative 1, my y-coordinate is negative 10. So I'm going to go here, negative 1, negative 10, put a dot. And then if I go back to my calculator, 0, 6. So 0, 1, 2, 3, 4, 5, 6. I'm going to put a dot right there. Go to the next one, 1, 10. So let's go back. 1, 10 is right there. So put a dot there. 2, 8, 3, 6. So 2, 8, 3, 6. 1, 2, 3, 4, 5, 6. And the last one is 4, 10. So 1, 2, 3, 4, 10. Okay. So it looks like it does something like this. We're going to try to curve this right here, go down, curve it up, and then over here it's going to go through this point, and I'm going to do my best to go down to right there. All right, there you go. So put arrows at the end of your line, and then make sure that it matches the graph that your calculator gives you. So I have something that looks like that. Yep, which is pretty much exactly what I drew. Okay, so that's question number 26. Question 33, this is straight calculator for partial credit. So out of the 4 points, you would get 1 out of 4. Listen, I'll take it. All right, so I went ahead and whatever was on the left side of my equal sign, I plugged it under y1. Whatever's on the right side, I plugged it under y2. So this is what it looks like. And then I hit graph, and hey, pause. They don't intersect, or it doesn't look like they do, but maybe over here it does, right? So I have to move the calculator over there. So if I do zoom, option number 0 is something called zoom fit. Let's see if that helps us. So I did zoom fit, and now that's my first curve. That's the y1. That's the second one, y2. Okay, so I can see a little bit better, but I still don't see what's going on over here on this side. So I'm going to go to window, and I want to change my x-min. Let me be dramatic with it. let me just go negative 50, and let me go to my y min right here and change this to negative 20 and see if that's a little bit better. All right, so now that's my blue, and does my red cross. Okay, there we go. So I just need to see what this point right here is. So I hit second trace. Option number 5 is intersection. So I'm going to move my mouse over, or my cursor over, hit enter, 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 and it gives me x equals negative 15. So algebraically, x is equal to negative 15, and I have gotten 1 point out of 4. Listen, I'll take it. It's something. All right. Next one. All right. First thing I did is I went ahead and graphed or plugged in my function, which is 12 cos. Cos is right here. Pi over 3 x close parentheses plus 8. And then I'm looking for the average rate of change. As soon as I see average rate of change, y2 minus y1 over x2 minus x1 should come into mind. This is for 2 points. So I'm looking at the numbers from 1 to 2. So if I go here, go to my calculator, go to second graph. I'm looking across from 1, I see 14. So my first coordinate is going to be 1 comma 14, and my second one is going to be 2 comma, what's the number across from 2? 2, 2. Okay, so 2, 2. So then I go x1, y1, x2, y2, and I plug it into my formula, right? My y2 is, let me close this parentheses before I get sloppy. So my y2 is 2, so I'm going to do 2 minus my y1 is 4, over my x2 is 2, minus my x1, which is 1. So I plug this into my calculator. So I'll go second quit, alpha y equals, nope, alpha y equals, option number 1. So I'm going to do 2 minus 4 on the top, and on the bottom I'm going to do 2 minus 1. There we go. Answer is negative 2. So that right there has gotten me 2 points. Check. And then at what value does h of t equal 0? So I'm going to go to my calculator here. I'm going to plug in 0 here, and I'm going to look to see where my two graphs intersect. So that's my blue graph, which is the actual function itself. And then the red graph. Stop texting my red graph is right there, and I'm only looking for the intersections between 1 and 5. So I'm going to hit second trace. Option number 5 is intersection. My cursor is where x is equal to 0, so I'm going to, good, that works. So I'm going to go to the right, somewhere right there, hit enter, enter, enter. This is for my second point. So it says to the nearest tenth of a second, so 2.2 is going to be one of my answers. So 2.2 is one of my answers. And then I'm looking to see what my second answer is going to be. So I'm going to go here. I'm going to do second calc option number 5, which is intersection again. And I want to see what this number is, as long as it's before 5. Okay, so that one, enter, enter, enter. And my second value is 3.8. So 2.2 and 3.8. And it looks like this other one over here is way past 5, so I don't need to write it. Okay. Last one. This question. Oh, by the way, this one was worth 4 points, so it's 2 points for this first part and 2 points for the second part. That was straight calculator. Last one, you just need to graph this, and out of the 6 points, you could get 2, which is great. All right, so I want to show you this from scratch. I just reset my calculator by doing second plus 7, 1, 2, and then that resets my whole calculator. So now I'm going to plug in log of x minus 4. Here's the log button. I do x minus 4, close those parentheses, and the question wants me to graph this right here. So just like I did before, I want to change my window. So my x is up until 20, and my y is up until, let's just say, 4. So I'm going to go here, go to my window. My x min is 0. My x max again was 20. 20. And then this is going up by 2's. So my scale is 2. And then my y min is 0 again, and my y max is, let's just say, 5. Okay. So now when I hit my graph, okay, so this is basically what I'm going to have to graph. So now I go here to second and table. So 5 comma 0. So I'm going to go see where 5 is, right? Between 4 and 6, right in the middle is where 5, 0 is going to be. So that's my first point. The next one, I'm going to look for like good points because the rest of them are like kind of hard to graph. Let's go ahead. Okay, so I can graph that 14, 1. So I go here to 14 and I go up to 1. So I put my dot right there. Let's see if there's another good point that I can graph. Nah. All right. So I know I know generally it's going to look something like a curved line. So I'm going to go like, let's see if I can do that better. You'll probably do this a lot better than me because you have paper. Okay. And then you want to put an arrow at the end of the line. And again, if you just do that, that gives you 2 points. And then if you keep reading, it says an alternate model is represented by this function right here. So I'm going to go ahead and go to my y equals and type my second function in, which is 1/2 x minus 6.